Okay, good morning, everybody. The situation for coronavirus is obligated all of us to start teaching online, and this is for the benefit of all of us. So let us start talking about the relationship between individuals and the inbreeding. Previously we defined the inbreeding in general, and I hope that you can remember it through from the last lectures. So I will go direct to define again the inbreeding. Inbreeding can be defined as the probability that the two genes present at a locus in that individual are identical by descent. Identical by descent. So this is the main definition for the inbreeding. And previously I give you that another definition for the inbreeding that talked about the relationship between individuals. The relationship between individuals. So the relationship between individuals and the relatives may the close relative actually may cause what we call the case of inbreeding between individuals. So first of all, we do need to understand what do we mean by half sips, because if we return back to the definition, we do need to understand the relatives cause such inbreeding cases. So the half sips and the full sips in general. Now, if you go, for example, if any sire mated with two dams randomly and produce two individuals, the first and the second son, as you see here, this is the sire, and also mated two different dams, and he produced as on offsprings, two offsprings, the first son and the second son. In this case, this is what we call the relationship between the two sons right here is half sips. They are half sips. بمعنى أنصاف أشقاء. They are not from the same dam. They are not from the same mother, but they are belong to what we call the same father. And actually, previously Lush create or innovate a procedure to understand the relationship between individual, and he concluded that from his very long equations, the relationship between the father and his son is 50% from 5. This is a normal relationship between you and your father, just only 50%. As I told you in the lecture, that my father is, I have 50% from my father's genes, sorry. And also, the probability of the first son to carry the same genes as his father is also half. It means that they are identical by descent, IBD identical by descent by 50% of the genes. So the probability of the first son to carry the same genes as his father is just only 50%. The probability of the second son also to carry the same genes as his father is calculated to be half, or 50%. They are identical by descent by 50% from the genes. If both of the probabilities are independent, and you do need to I refer here to the probabilities lecture that you have taken through the biostatistic lecture, and you do need to understand it well. The probability for the first and the second son to carry the same genes is half multiplied by half to be equal to 0.25. Okay, this is why they are independent events. If you return back to the probability lecture and the biostatistic, you do need to understand that we do need to multiply the first probability by the second probability, and you will obtain the result. So both the probabilities are independent. The first and the second son to carry the same genes. The second, we are talking about the first and the second son. How much do they need to resemble each other or identical by descent? They will be 0.25 because of they are half sips. Now the story of full sip is totally different. Right now we have two male and female, or sire and dam, and both of them produce two individuals or two offsprings. They are, both of them are from the same sire and from the same dam. In this case, we don't have another dam to produce different son from the same sire. So the relationship between the father and his son, as usually, is 0.5. The probability of the first and the second son to carry the same genes as the father is 25. 0.25. They are identical by descent, and the probability of both of them to carry the same genes as their mother is 0.25. They are identical by descent. In both cases, the probability are independent, as we discussed previously, and for the first and the second son to carry the same genes, the probability from the both sire and dam is 0.25 multiplied by quarter also, and it will generate 0.5. This is the probability of the two genes or the two sons, the forceps, to carry the same genes and identical by descent. Now, from the inbreeding coefficient, or from that relationship, we can go directly to the coefficient of relationship that has been created by Wright 1921, and he also added another reference that is teach all around, all breeding students took it in all around the earth and all universities. Wright equation 1921 and also 1922. He suggests the probability in a quantitative way. He also returned back to this relationship or the probability, and he studied it in different angle. So, calculation of the coefficient of relationship between the individuals. In the example, suppose that we have this pedigree, and we do need to calculate the relationship between X and Y. X and Y. This is the pedigree, and as you see, we do need the question is, what's the relationship between X and Y? Now, in order to solve such problems and to know the relationship between those individuals, we will rewrite the relationship in different arrow to indicate the direction of inheritance. This is what do we need, just to go for rewriting the relationship, just to indicate the direction of the inheritance. So this is X and Y, they produce X, and A produce Y, and from this dendrogram of this relationship, you can conclude that X and A are the father and the dam for Y. The relationship is a direct one right here. That means that the individual X is a father for individual Y, and individual X is a common ancestor. And why do we need we concentrate on X? Because we do need to study or calculate the relationship between X and Y. From this calculation, from this arrow or this direction, we can observe that X is father for Y, and X is the common ancestor. In all problems, we do need, whatever the complication relationship between the individual, we do need to look for the common ancestors, الآباء المشتركة, the common ancestor. The first of all, we do need to look for the common ancestor, and this is a common ancestor, just only a direct relationship, and we can calculate it directly, or we do need to look for the path direction. The path direction, it means X will produce Y direction. You can see this spear, a direct spear from X to Y is just only one spear, one path، ممر واحد فقط لا غير، أو سهم واحد من X إلى Y. لذلك نتعامل مع direction 1. We deal with just only one direction, one path or one spear. So the probability of having the same genes because of this relationship is about half to the power of 1, where 1 is the number of pathways. Now, we do need to conclude something from this relationship. The general formula for obtaining the relationship between the individuals is just only half to the power of n. And in here is the number of pathways of the spheres that can be counted from the different individuals that we need to calculate the relationship between them. First of all, we do need to look for the common ancestors, counting the pathways or the spheres from the first and the second or the targeted individuals that the relationship to be calculated for them. Then counting them, applying the equation half to the power of n. N is the number of pathways or the spheres from, for example, x and y. And this, in this case, we have coefficient of relationship is r, denoted r, rxy. Rxy, it means the relationship between individuals. It means the relationship between x and y individual. And in this case, it will equal to half to the power of n, and in here is 1. Because of this, just only one sphere, it will yield half also, not more.